In Unit 4, we talked about different types of triangles and their properties and some other triangle theorems. So up top here is just a refresher on the different types of triangles. So equilateral means 3 equal sides and all 3 angles are equal, which means they would have to each be 60 since 180 degrees divided by 3 is 60. Isosceles triangle means 2 equal sides and the angles across from those have to be equal. So make sure it's always the angles across from the equal sides. And then scalene means no equal sides, no equal angles. Right triangle means you have right angle in the triangle. And it can either be isosceles or scalene. So with a right triangle, you could have 2 equal sides, which would make it isosceles, or you could have all 3 sides are not equal, which would make it scalene. So down below, using the different types of triangles, let's go ahead and solve these problems. So the first one here we have AB is congruent to AC. So these two segments are congruent. So right away I know that that triangle is isosceles, which means that these base angles, the angles across from the congruent sides, have to be equal. So if I know that the measure of angle A is 30, we're trying to find the measure of angle ACD. So ACD is this angle out here. The first thing I want to do is I want to figure out these base angles. So what I'm going to do is I'm going to do 180 minus the 30 and then just split that evenly between those two angles. So if I do 180 minus 30, I get 150. And then that means that those two angles have to add up to 150. So 150 divided by 2 gives me 75. So each of these angles would have to be 75 degrees. So then to figure out x, well, I know that these two angles are supplementary. They form a straight line, so they have to add up to 180. So if I do 180 minus 75, that'll give me 105, which means that the measure of angle ACD is equal to 105 degrees. The next one here, it says given angle A is congruent to angle C, so if I mark those, we know the measure or the expressions on AB and BC. Find the length of BC. So first thing is, as soon as I know I have two congruent angles, I know that the sides across from those are congruent by the isosceles triangle theorem. So since it's an isosceles triangle, so I can set those equal to each other. So BA is going to be equal to BC. So set them equal. So we have 3x minus 2 is going to equal 5x minus 10. Subtract 3x from both sides, add the 10 to both sides. So when we do that, you get 8 equals 2x, divide by 2, so you get x equals 4. Now that's not the answer though, because it says find the length of BC. Remember, if this was a multiple choice question, x equals 4 would be one of the choices, but finding the length of BC is the final answer, so you actually have to plug in. So BC is going to be 5 times 4 minus 10. So we would get 20 minus 10. So that means BC is equal to 10. So make sure you plug in, especially if this is a multiple choice question, you're going to see that answer, that first answer in there, but that's not the final answer. On the next page, we have some processes for coordinate proof. So how do you prove a specific type of triangle on a graph? So if you have to prove an equilateral triangle on a graph, you're going to use distance formula, and you're going to show that all 3 sides are equal. You can't prove angles on a graph unless it's a right angle, so you're going to use sides to be able to prove it's an equilateral. If you're trying to prove it's isosceles, well, you show that you have 2 equal sides using the distance formula. If you have to prove you have a scalene triangle, you have to show that you have no equal sides using the distance formula. And then the last type of triangle is a right triangle. Right triangles are a little bit different because that's the only triangle that you prove using the angle instead of its sides. So for right triangles, you're going to use the slope formula, and you're going to show that the slopes that form the right angle are negative reciprocal slopes. So let's actually do the proof for right triangles, just so you can kind of get the idea. So in this example, we want to prove it's a right triangle. So the first thing is I'm going to write out my plan for this. So I'm going to use the slope formula to show that the sides forming the right angle have negative reciprocal slopes. So basically it's what it says up here for number 4. So now we go ahead to the math step, which is to actually do our calculations. So you can use the slope formula here. So y1 minus y2, or you could say y2 minus y1, whatever you like. So change in y's over change in x's. Or you can use the graph. If I'm going to use the graph, then that means I want to plot my triangle. So I have 5, 6 is P, 8, 5 is Q, and then R is 2, negative 3. So for this one, it's kind of hard to tell which angle is the right angle, but to me it looks like angle P is going to be the right angle, so that's what I'm going to start with, and if it happens that those two slopes are not flipped and negated, then it must mean that angle Q is the right angle. So since I think the angle P is the right angle, that means I'm going to find the slope of this segment and of this segment. So you could use the slope formula to do that, or you could just count. I think a lot of you prefer counting, so that's the way I'm going to go with it. So if I start with this side here, I'm going to have to count from R. So up 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's up 9, then over 1, 2, 3. So that slope there for RP, make sure you label what slope. So M stands for slope, RP is the segment we're looking at, is up 9, right 3. So up tells me it's positive 9, right tells me positive 3. So divide those, you get positive 3. So then we move to the slope of PQ. So starting at P, I had to go down 1 and then over 1, 2, 3. So down 1, right 3. So it's rise over run. So then that means down is negative, positive 3 on the bottom since it was right, which this reduces to negative 1/3. So if we compare these two slopes, they are negative reciprocals. They are flipped and negated. So these are negative reciprocals, which means that angle P is a right angle. So now I'm set to write my conclusion. So my conclusion for this, I can say triangle RPQ is a right triangle because the slopes of RP and PQ are negative reciprocals, making angle P a right angle. So that's it. So your conclusion doesn't have to be exactly like that, but you do need to say that you have a right angle, so it's a right triangle, and it's a right angle because the slopes are negative reciprocals. So remember, the other 3 types of triangles, scalene, equilateral, and isosceles, you just can use the distance formula, or you could even graph them and use Pythagorean theorem to find the lengths of the sides, and then you just compare those to make your conclusion. But right triangles are the different ones. That's where you're using slope to prove you have a right angle. Remember, length does not prove a right angle. You have to do slope to show that you have flipped and negated slopes. On the next page, we have some other theorems that we talked about. So one of them we've used all the time is just the sum of all the angles in a triangle is 180. So for this problem, they give you the measures of the angles of a triangle are in a ratio. So whenever you see a ratio in this sense, really what you want to think of is the angles are going to be 2x, 3x, and 5x. So whenever you see ratio and you're trying to figure out what the value of x is, or what the common factor is between these, you're going to just plug in an x and then set up an equation. So what is the measure of the largest angle? So the first thing you know is that these three angles have to add to 180. So 2x plus 3x plus 5x equals 180. And then you're going to solve it. So adding those up, I get 10x equals 180. Divided by 10, I get 18. So then if I want to find the largest angle, again, x equaling 18 is not the answer. The largest angle would have to be 18 times the biggest number here. So 5 times 18 is going to equal 90. That's going to be the biggest angle. The next theorem that we talked about was the exterior angle theorem. So that's the sum of any two interior angles is equal to the non-adjacent exterior angle. So basically, the two angles that don't touch the exterior angle, those are going to be equal to the exterior angle. So not this angle here. So if we look at this example, we have this situation. We have angle A is x, angle B is 2x plus 15, and ACD is 5x plus 5. We want to find the measure of angle B. So again, not just solving for x, but once I get x, I'm going to have to plug back in. So these two angles are going to add up and equal the exterior angle. So my setup is going to be x plus 2x plus 15 equals 5x plus 5. And then solve for x. So combine like terms here. So I have 3x plus 15 equals 5x plus 5. Get your numbers on one side and x on the other. So bring the 3x over, bring the 5 over. So those cancel. So I get 10 equals 2x. Divide by 2. So you get 5 equals x. Now remember, it says what is the measure of angle B? So this is step 1. Step 2 is to find the measure of angle B by plugging in. So I'm going to plug in 5 into this. So I have 10 plus 15, so we get 25. So that's the answer for this one. So that's just using the exterior angle. So the two non-adjacent, or two angles that are not adjacent to the exterior angle add up and equal that exterior angle. So the next page, we have another theorem, which was the triangle inequality theorem. So this says that the sum of any two sides of a triangle is greater than the third side. So if you have multiple choice questions where you just have to decide which set of sides will form a triangle, you just have to check any two sides must add up and be greater than the third. But what if you have an example like this where they give you two sides, so they give you 3 and 6, and they want you to find the possible integer lengths for the third side. So this is where you're going to set up and you're going to follow this process here. So what's going to happen is you're going to add the two sides. So I'm going to add 3 and 6. That gives me 9. Then I'm going to subtract them. It's always going to be big minus small here. You don't want a negative side length. So you get 3 and 9. So that means that the third side has to be greater than 3, but less than 9. That's what this is saying. So using that, I make that conclusion. The third side is in between 3 and 9, greater than 3 but less than 9. So if I want the integer values, that means the whole numbers. I'll write integer lengths. That would be, so greater than 3, so not equal to 3. So we'd have 4, 5, 6, 7, and 8, because you can't equal 9. So those would be the possible side lengths that would form a triangle using 3 and 6 to start. The next theorem that you talked about was the Pythagorean theorem. So just remember, Pythagorean theorem, the longest side is the hypotenuse. So this is the hypotenuse. That's what's going to go in for C. And then A and B are just the legs. So these you can swap, it doesn't make a difference, but the hypotenuse is always along the side, always across from the right angle. So Pythagorean theorem has a couple different uses. If you're trying to find the missing side of a right triangle, you can use Pythagorean theorem. Also, if you're on a graph and you want to find the length of a segment, and you just basically make a right triangle using that segment as the hypotenuse, so that you can use Pythagorean theorem. So a lot of people prefer that, it's quicker. The other thing you can use Pythagorean theorem for is to decide if a triangle is a right triangle. So if you're trying to decide if a triangle is a right triangle, you plug the three side lengths in, plugging in the longest side for the hypotenuse, and if those numbers work in the Pythagorean theorem, then that would mean that your triangle is a right triangle. So for that one, like, let me just show you. If I had sides equal to 3, 4, and let's say 6. If you wanted to check to see if those form a right triangle, what you do is you plug into the Pythagorean theorem. So the longest side has to go in for C, and you see if it's equal. So this would be my C squared, it's the longest side, and then 3 squared plus 4 squared are my shorter sides. So I actually do these. So it'd be 9 plus 16, and I want to see if that equals 36. So if you add 9 plus 16, you get 25, and that does not equal 36. So the conclusion you can make is the sides 3, 4, and 6 do not form a right triangle because they don't work in the Pythagorean theorem, because they don't satisfy or work in the Pythagorean theorem. So you could also use that for right triangle coordinate proofs. If you found the distance of the three sides, you could then plug them in, and if they work in the Pythagorean theorem, you prove that you have a right triangle. So that's just another option. And then the last page in this section is just the different vocab for different segments in triangles. So a median, remember, connects to the midpoint. So connects to the midpoint of the opposite side, which means if this is the midpoint, that means that you have two congruent parts. So AD here is the median. And altitude is the height, so also known as the height. It always has to be measured perpendicular to the opposite side. So if you look, you have all these right angles. Altitude is always measured, so it's perpendicular. So basically the altitude and the base would have negative reciprocal slopes since you have a right angle. The angle bisector is going to divide the angle into two equal parts. So here's your two equal parts. You're cutting this big angle into two equal parts. And then perpendicular bisector means that you have perpendicular, and so right angles are formed, and it's bisecting. So it's this point right here is the midpoint, and it's cutting this segment into two equal parts. So you get two congruent segments, and it's perpendicular. Now, keeping in mind, perpendicular bisectors do not have to pass through that vertex. They can, but they don't have to. It depends on the different type of triangles.